Hello everyone, I hope you're doing well wherever you are. So today we'll be looking at May-June 2024 Paper 2 Variant 2.2 from Cambridge Physics A-Level. So if you're new to this channel, welcome, and if you are returning, welcome back. Today we'll be looking at question 4. Okay, so let's do this together. A pinball machine uses a spring to launch a small metal ball of mass 4.5 times 10 to the power of negative 2 up a ramp. The spring is compressed by 8 times 10 to the power of negative 2 meter and held in equilibrium as shown in figure 4.1. Okay, so this is the figure. We have our compression length. We have the incline angle, which is 15 degrees. It's actually a bit inclined. Okay, no problem. Let's see what the question wants. The ramp is at an angle of 15 degrees to the horizontal. Okay. A. The spring obeys Hooke's law and has a spring constant of 29 Newton per meter. Calculate the elastic potential energy in the compressed spring. Okay, there's actually two ways to solve A. I'll show you the first way first. We know elastic potential energy has this formula 1 over 2 kx squared, right? It is given spring constant is given, and we have our compression length, which is 8 times 10 to the power of negative 2. Before you proceed to perform your calculation, check your units. Make sure both are in meter. If they are not, please change it, otherwise you'll get an incorrect answer. Okay, don't forget that. These are the small minor mistake that will cause you to lose a lot of marks, which we don't want, right? Okay, then our compression is 8 times 10 to the power of negative 2. Don't forget to square. If you don't square, you will get a very different answer. So I'll go ahead and grab your calculator. Let's calculate this. So you will get 0.0928 joules. In physics, you can put 3 significant figures, but minimum you must have at least 2 significant figures. You must have at least 2. If your answer is correct, but you have 1 significant figure, you'll be marked as wrong. So please do not do that. Make sure it's in 2 significant figure minimum. 3 is fine. Okay, I usually put 3 because sometimes we need to use it in the next question. No worries, 2 is also fine, 3 also fine. Minimum is 2. Okay? Alright. So this is actually the first method. Now what is the second method? Second method is just another formula. Remember, there's another formula for elastic potential energy, which is 1 over 2fx. But this one you need to do a bit of extra work, which is you need to find what is your F is. So we know F is equals to kx, right? So your K is 8 times 10 to the power, your K is 29. Sorry, your K is 29. Your X is 8 times 10 to the power of negative 2. So when you calculate this, it is actually it's almost similar to the first one. It's just a different way of approaching it. You will get 2.32. So what do you do now? You sub inside your equation. 1 over 2, 2.32. Your compression was 8 times 10 to the power of negative 2. You don't need a square here, so don't go and square it, okay? Please be careful, because you don't want to lose any marks. And you will get the exact same answer, 0.00928 joules. It's the same answer, just 2 different ways of doing it. You see which one do you prefer. If you ask me, to save time, I would definitely recommend the first method lah. Recommend it because it saves a lot of time, because you just have to sub in the formula, right? Okay. Now, okay, that's it. Just nice, you got your 2 marks. Make sure your units are careful, and if there's a square, don't forget to square. Okay, B. The spring is released and expands quickly back to its original length. Okay, calculate the increase in gravitational potential energy. Wow, okay. of the ball when the spring returns to its original length. Okay, now they want us to find the GPE, which is the gravitational potential energy. Okay, so now the spring is compressed. Once it is released, it's going to be at this point, right? So now we need to find what is the height from here to here, because initially it was at here. Now after it is released, it's definitely going to go up the ramp, so it's going to be here. So how do we calculate this? This involves a bit of maths knowledge, where you learn angles and maths, right? If you still remember, the angle here and the angle here are the same. So that means this is also 15 degrees, because these two are parallel. So if I can see, this is 15, this is also 15. Okay, let me draw for you outside. So now we know this is 15 degrees. How about this angle here? It has to be 15 degrees, so right? This is something we learned in maths before. It's angles that are the same in this form. Even if it's like this, these two angles add up to 180. Remember? Right. So this is just one of it. So now we are looking at this one. Okay. Right, so let me erase that. Okay. So I will draw this again at the side for you to clearly see. Because sometimes in exam, right, when you're under time constraint, time pressure, you will be thinking where to find the angle. That's why when you do past year papers, it's best to practice under time constraint. Because it's not that you don't know, but it's just that under pressure sometimes you can't think straight. It's okay, I understand. So whenever you do practice past year papers, do it under time constraint. Practice yourself under it. But anyways, coming back to the question. So this is 15 degrees. We know this length is 8 times 10 to the power of negative 2, right? This length here is the compression length. And now we want to find what is this. I'm going to make this as y. So this is Pythagoras theorem, because we have a right angle triangle. We want to find what is the opposite. But we have the hypotenuse, we have the angle. So what can we do? Make use of sine. So sine 15 degrees equals to opposite over hypotenuse. So your y is, make sure your calculator is in degree. If it's in radian, you're gonna get a very different answer. Please make sure all this when you're calculating. You'll get 0.020706. Okay, let's just take this value. Meter. That's the height. You see, this is the increase in height. This is basically the increase in height. Make sure you do this working here, okay? At this empty space. I'm doing it here just to show you, but make sure you do all this working here, because they need to see that you are doing it there. Okay, right. So let's write down the formula. Oh, one more thing I forgot to mention. In physics, right, if you write down the formula itself, you get 1 mark, Really, even though if let's say you don't know how to do the question in exam, you're not sure, just write down the formula, you'll get a mark. But regardless, if you know how to do, just do the question. Just do something. Don't leave anything empty. That's what I'm trying to say, is don't leave anything empty. But after watching this video, trust me, you'll be able to answer the question, okay? No worries, I got your back. Okay, alright. Okay, so they're finding gravitational potential energy. So we know the increase in gravitational potential energy. You can write EP also if you want, but I am just used to writing gravitational potential energy. But EP is also fine. mgh. Change in height because we're finding the increase in gravitational potential energy, right? Okay. The mass, I believe I saw the mass somewhere. Yeah, it's given here. 4.5 times 10 to the power of negative 2. Is it in kg? Please check. It is. Perfect. Gravitational acceleration is 9.81. Increase in height just now we saw 0.020706. Actually I copied correctly. 0.020706. Okay. Now take off your calculator and you will get... Okay, wait, let me calculate. 9.14 times 10 to the power of negative 3 joule. I'm writing this in 2 significant figure. If you want to write it in 2, it's 9.1 times 10 to the power of negative 3 joule. It's the same. No difference. I'm just used to writing in 2 significant figures. Okay? Right. Moving on to the next question. The ball leaves the spring when the spring reaches its original length. Assume that all the elastic potential energy of the spring is transferred to the ball. Calculate the speed of the ball as it leaves the spring. Okay, to do this, we actually need to form an equation. But before forming an equation, let's look back at the diagram. Okay, so initially the ball was here. Wait, okay, just now I think I made a mistake saying the ball was here, right? Apologize for the mistake. The ball is actually here. Okay, but other than that, the calculation is still the same. It is still 15 degrees here. It is still using the same maths knowledge. Okay. Anyways, initially the ball was at this point and it moves up to this point. There's an increase in height. And since there's an increase in height, there's gravitational potential energy, which we have calculated in B Roman 1. And now they say there is speed. That means there is also kinetic energy, because they say there's a speed as the ball moves up the ramp. So what do they mean by assuming that all elastic potential energy of the spring is transferred to the ball? That means elastic potential energy is equals to kinetic energy plus gravitational potential energy. If you say that elastic potential energy is just equals to gravitational potential energy, you are actually wrong. Why? Because if elastic potential energy is equals to gravitational potential energy, ideally your answers in A and B supposed to be the same. But they are totally different. They are not the same. That means there is an extra energy in it. And that energy can either be kinetic energy, or you might even have work done against friction as it moves up the ramp. Now, you might ask, why didn't I mention about friction here? Because, first of all, they did not say it's a rough surface. And the best part, they did not even say it's a smooth surface either. However, for you to calculate work done against friction, you need the frictional force. And no frictional force is given. And you have not really any information to calculate the frictional force either. So we completely ignore frictional force in this case. So your equation is just elastic potential energy equals to kinetic energy plus gravitational potential energy. Okay, so we know our elastic potential energy is 0.0928. 0.0928. Our kinetic energy is... So, okay, here's a two-way you can do this. You either find the kinetic energy first, or you substitute your kinetic energy formula right in this equation if you want to do it fast. Both ways, it's fine, but make sure you calculate it properly. I'm going to do it one by one, okay? So your gravitational potential energy is 9.14 times 10 to the power of negative 3. So take your calculator out, and it's time to perform some calculation. So your kinetic energy is actually... Make sure you minus properly. Okay, do not do any mistake along the way. And you will get your kinetic energy as 0.08366. Okay. Yep. So we know kinetic energy is 1/2 mv squared. So it's equivalent to this. Now what you do is you take 1 over 2. What's your mass? Your mass is 4.5 times 10 to the power of negative 2 is given. We have used here just now also. V square is what we're trying to find. So you do your math. You get your V is equivalent to 1.93 meter per second, but you'll get positive negative because there's square root. But since they're asking for speed, you can just write 1.93 meter per second, because speed is a scalar quantity, so the direction doesn't really matter. Okay, now C. So C is actually a bit on moments. I like how they inserted a small part of moment in this question. The ball comes to rest on a horizontal trapdoor of negligible mass at a distance d from the pivot. Where's the pivot? Oh, the pivot is here. A force F acts vertically downwards at a distance of 2 cm from the pivot as shown in figure 4.2. Okay. The trapdoor is in equilibrium when F is 1.7 Newton. Okay. This is the weight of the ball. And definitely it's going to move this way since the pivot is here, and F is going to move this way. So this is anti-clockwise, this is clockwise. So summation of anti-clockwise, ACW is anti-clockwise, is equals to the summation of clockwise, CW is clockwise. I am doing this, I can do this way because they say it's equilibrium. That means both sides should result in the same value ideally, because it's not moving. It's like balanced force. Force are balanced because they say it's in equilibrium. So we have 1.7 Newton. What's the distance? It's in centimeter. Make sure you convert to meter. Okay, do not forget, these are the small things. Clockwise, the mass is 4.5 times 10 to the negative 2. But since, remember, we are getting the force. Ideally, in this case, is the weight of the ball. So, make sure to times 9.81 because W is equals to mg. You can choose to do this separately, then get back to this, or just want to put in the formula. No problem, up to you. We're going to get the same exact answer, and we're going to find what's D. So, you perform your calculation, do your math, and you'll get your D as, okay, let me do first. 4.5 times 10 negative 2, 9.81. I am getting 0.077 meter. Yep. Or you can also write it as 7.7 times 10 to the power of negative 2 meter. I think this looks a bit nicer, right? But it's the same. It's the same answer. Anything you like. Yeah, so that's the answer. Easy, right? Simple as that. 3 marks for you. Force F is decreased from 1.7 Newton. Oh, okay. State the direction of the resultant moment about the pivot on the trapdoor. Okay. So another way to calculate resultant force is, want to calculate the resultant, not resultant force, resultant moment, is you take the clockwise minus anti-clockwise. Actually, not really minus. It's just clockwise, you set it as positive. Anti-clockwise, you set it as negative. That's why it's minus. Okay. So now, your 1.7 Newton is decreasing. So that means your anti-clockwise will decrease. If you're not sure whether it will decrease or increase, don't worry. Take out your calculator. Try taking 1.5 times by 2 times 10 to the power of negative 2. 1.1 times 2 times 10 to the power of negative. You realize the moment will be decreasing. So when this moment is decreasing, that means a value minus a smaller change. What will happen? You will get a larger value, right? So if you get a larger value, it's more positive. And we have set clockwise to be positive, like I said just now. Anti-clockwise is negative, clockwise is positive. Therefore, your answer is clockwise. Let me give you an example, okay? In case you still don't get it. Let's say my clockwise moment. Okay, let me calculate my clockwise moment first. Times I will get 0. Okay, wait, let me write this. Zero point 0.03399. This is my clockwise. Okay. Now my anti-clockwise, like I said, 1.7 is decreasing. So let's, because they say it's decreasing, so just put 1. 1 times by 2 times 10 to the power of negative 2. So let's see what do you get when you minus this. You will get 0.01399. This is a positive value. Earlier we already said positive is clockwise, negative is anti-clockwise. That is why there's a negative here, because this is anti-clockwise, right? But you can set the other way around also. No problem, as long as you're consistent with it. So I got a positive value. So what does this mean? It's going to be clockwise. So my answer will be clockwise. Do not put the exclamation mark in exam. Okay. There you go. You obtain your 11 marks. So actually this question, the first part is more on energy, and the next part is a bit on moment. So very importantly, first thing, your units, your squares, and this angle. Like I said just now, it's a small maths thing that you might need to refresh, before you're doing the paper. Other than that, I believe you'll get those 11 marks. You can do it. All you need to do is stay calm and breathe. And don't forget to stay hydrated. So that's all for today's video. I'll see you in the next one. Bye bye.